All right, and what we'll do is we'll go ahead and share my screen. Nope, not that. There we go. Okay, so data structures. So we're going to talk about data structures. Now this class, this particular class is not going to be a very involved discussion on data structures. It's not going to be a lot of information about data structures. It's more just kind of to introduce you to some of the ways that we can store information, to some of the ways that we can store data. Okay, so basically one of the data structures you've become very familiar with, that you became very, very familiar with last semester, was the array. All right, so this was a way to store lots of information together, so you could have an array. And remember, in Java, we can have an array of anything. It's not just an array. It's not just arrays of primitive data types. So you don't just have an array of ints or an array of doubles or something like that. What you're able to have, you can have an array of objects. Right? Harder for us to think about strings as objects because they do kind of look like a primitive data type, but in Java, strings are objects, and we can have an array of strings. In fact, a string array that you use a lot is that args array, to the main method, right? So arrays, we have lots of different things that we can put into an array, but an array is not the only way to store a group of objects or a group of anything. In fact, there's lots of different data structures, and when you get into your data structures class later, I think it's either next semester or the spring or next spring, you will learn all in more detail all about these particular types of data structures. We'll just kind of talk about a few here today to help introduce you to the whole idea. Okay, so please, read through objectives, on your own. I won't go through this. Okay, but the basic idea that Java has, remember, Java is an object-oriented language, and so a lot of the way things operate in this is going to be through inheritance, through having this one class type or one interface that other things will inherit from that, right? So the way that gets implemented in the Java hierarchy is this idea of a collection. Okay, so you can have, and what I'm just going to skip a couple slides here to show you this right here. So you have this parent interface thing called a collection. Okay, and remember, this dashed line shows not extends, but it shows instead implements, right? So this indicates that this is going to be an interface, right? So a collection can be lots of different types of collections. We can have sets, we can have lists, and we can have queues. There are some differences between these different things, right? These different types of collections, but there are some similarities. There are some things they have in common, and so that's why we have this parent interface called a collection, right? That just means a group of things, right? It just means a group of things together. Now, a set, and you'll get into this, I don't know if you've gotten into this in your math classes with set theory and all of that, and how Venn diagrams work and all that. But sets, basically, it's just, is something a member of the set or is it not a member of a set? Order doesn't matter. It's not an ordered, there's not an ordered set of things. It's just a matter of, is it there or is it not? And one of the things about a set is that a set can't have duplicates. So if 3, let's say you had a numerical set that was an integer set, okay, a set of integers, right? Now, if 3 is in the set, maybe we might even say, let's say it's the set of prime numbers, for example. If 3 is in the set, then it can't be in the set more than once, right? Because that wouldn't make sense. I mean, 3 is either in the set or it's not. 4 would be not in the set, right? And so it's more, so for a set, it's not ordered, but it also can't have duplicates. Okay? A list, on the other hand, is a little bit different. A list is ordered. All right. A list is an ordered group of things. So you put something first in the list, and second in the list, and third in the list. And the thing with a list is a list can have duplicates. So if we think of an array being more like a list than a set, okay, and we're going to get down to this where we end up having this thing called an array list, all right, okay, where an array list is a type of list, right? Then things become ordered, and we can have duplicates, okay? And so you may, I know the question always comes up, well, which is better? Is a set better or is a list better? Well, it depends on what we're trying to do, okay? And again, like I said, really detailed and really in-depth discussions on these data structures is beyond what this class is about. This is more just an introductory kind of dip your toe in to the water, just kind of get a little bit of a feel for what data structures are all about. Okay, so I don't want to get too much into this. So I just want you to know, for now, what you need to know is that a set is unordered, does not allow duplicates. A list, on the other hand, is ordered and would allow duplicates. Okay. All right. But they all inherit from, they all implement this collection interface because they're both a type of collection, right? There are some differences between the two: unordered, ordered, no duplicates, duplicates allowed. But there are also some things they have in common in that they're both a group of items. Okay. Okay. So let's move along. Okay, so here's the collection interface. So some of the things we want to be able to do to any collection, whether it be a set or a list or whatever, is we want to be able to add things. We want to be able to remove things. We want to be able to have an equals method that tells us whether or not two things in the collection are the same. You know, we want to know what the size is, how many things. One useful tool in our collection interface is going to be the toArray method that will take everything in the collection, whether it be a set or a list, and make it an array of whatever it is. Okay, so it returns an array of the objects for all the elements that are in the collection. Okay, iteratable, we'll talk about that. Iterable, because it is a collection, we want to be able to iterate over. Remember iterator, iterate. Now we're introducing this new word, iterable. Remember, this is when we talked about loops and we talked about I being an iterator. Basically, to iterate just means to be able to go through things one by one. So last semester we talked about iterating over an array. All right, which just meant having a loop, having an I variable as an index for the array, and going through that array item by item. So for a collection interface, it implements the iteratable interface, which means that we can go through any collection item by item. Okay, and we can use that using the has next, go to next, right? Get the next thing. Remove something, right? So has next, both of these methods should look familiar. You use them, right? You've used them when we did file reading, right? So you can kind of look at reading a file as being a collection of lines in the file, a collection of characters in the file, a collection of strings in the file, however you want to look at it. A file is a collection, right? There is something there. There is a bunch of things that are all the same thing that are in there, okay? And so we're able to use that has next stuff, right? Okay. So, okay. As I said, a list is an ordered is an ordered interface. It's an ordered collection, and it allows us to specify where an element is stored by index. So in other words, just like with an array, we also did this with array list, that if we want to get the first item in a list, we just access it by its index, 0. Right? And it's always n-1, whatever the position is that we want, -1. Java uses what's called 0 indexing. Okay. And we'll see that with, we'll also talk about a different type of list today. We'll talk about the linked list. Okay. And we'll look at an example of linked list versus array list. Okay. All right. So some of the things that we have in the list interface, right, is notice that these are some of the same stuff, add, but there's some different things here, right? Because for a list, we want to be able to get by index. We also want to be able to pass an object and say, if this exists in the list, we want to know what its index is. So remember, this is like a string, right? If we want to find a character in a string, we would want the index of that character. So we're adding this to our list utility. Okay, we're adding this to our list ability. All right. Okay. We want to set something at a certain index to be an object. So remember, so this would be like taking that array at index whatever equals something, right? This would be to set that at a certain index to give it a certain object, a certain value. Okay. We can create a sub list, a smaller list from an index to another index. Right. These are all things that we would use with a list type data structure. These things would not make sense in a set interface because an index of a set doesn't make sense, because in a set it's just what things are there, is the thing there, and so we wouldn't be able to get a thing from a set by an index because it doesn't have a position. It's not an ordered thing. Okay. All right. So I'll skip over this, but basically it's the same thing. The list iterator is very similar to the collections iterator. All right. Now, this is where I would refer you to the other video recording that I'm going to do for this, because this is much more, in my opinion, more understandable through a visual understanding. But we have two types of data structures that get used quite a bit as far as lists are concerned. One is the array list and one is the linked list. And which one is better, which one is worse, entirely depends on how you intend to use the list. Okay, there's not a one is better, one is worse all the time. But what I can tell you is that the array list, because its core structure underneath acts like an array, is an array, but we can easily access items by index. A linked list, however, we access it by index, but the way to get to it is slightly different. Okay, I really think this is much better explained using, like I said, a whiteboard type of thing. So I'm gonna, like I said, I'm gonna record this video and I'm gonna record this separate video and talk about it there. Okay, so just look out for that. It'll be uploaded hopefully within the next day or two, and you can have a better visual understanding of how this works. Okay. All right. You'll understand why the array is better for accessing, but a linked list is better for inserting and removing. Okay. All right. So an array list implements the list interface, so it has access to all of the list methods. It has to implement all those abstract methods. Okay. Linked list, same thing. It has to implement all of those list abstract methods. Okay. All right. And we can look at an example using the array and linked list, and I have it queued up and it'll be ready to go in just a moment. We'll look at it. All right. So this is what it would look like, but we'll just go through that one. All ourselves. Okay. Comparator, we talked about the comparable interface and implementing it. Comparator is a little bit different. So it's another tool that we can use to compare two different objects to see which one is greater and which one is less. So there's multiple ways to be able to do a compare to compare two things. Now remember that if we want to compare two things, we either have to make them instances of comparable, which would mean by themselves they're inside of that class, inside of that object's definition. There would have to be a compare to method defined and useful, and it would have to implement the comparable interface. But if elements are not, if they don't implement the comparable interface, but we have a need to compare the two of them, we have a need to see what the differences between two objects are, we can use a comparator to compare those two elements. Okay, so there is an example of that queued up as well. And if we have time, we'll look at that one as well. This one's a little bit less important to me because you can make things comparable using the comparable interface instead. This is just a second way, another way that we can do it. It just depends on how we want to define them. It's just a question of where we want the compare to aspect to be done. Okay. All right. So just like before, the compare method here, instead of the compare to, the comparator interface compare method takes two objects as what it gets passed, and it basically returns a negative value if element 1 is less than element 2, a positive value if element 1 is whatever greater means is greater than element 2, and 0 if they are considered equal. Okay. And we'll look at, if we have time, like I said, we'll look at this example. If we don't get to it in this video, I encourage you to go ahead and look at this as another way to compare two objects of the same type. Okay, so in this case, it's two geometric objects. Okay. All right. So the collections class, now this should not be seen as the same thing as the collection interface. So that back up here, if we look back up here, we have the collection interface, and we also now can look at the collections class. Okay. It can take a list and sort it, right? It can take a list and sort with the given comparator. So this here, in order to just use the sort with the list of whatever the things are, then the list must be consist of objects that are comparable, that implement the comparable interface. If they don't, so if we have some other object types that aren't on their own comparable, we must define a comparator for it in order to sort them. Like I said, this one makes it easy if the objects have, if the class here, the type of objects here have comparable already defined. Here, if they don't have it defined, then we just maybe define a comparator. Okay. And so then same thing with max and min. The only way we understand what a maximum of something is or a minimum of something is depends on whether or not the two things are comparable natively. If we've defined a compare to method, implemented the comparable interface, or if we have defined a comparator and passed it along. Okay. I do want to talk about the stack because I'm gonna skip over the vector class because I'm gonna let you hold off onto your data structures class for that. I do want to talk about the stack class because it's pretty useful data structure, right? And I've talked about it before that we can push and pop. We can push things to the top of the stack. We pop off of the top of the stack, right? We can peek, which would return the top element, but does not take it off. That's the difference between the pop and the peek. peek just gives us what the top value is, what the top part of the stack is, without removing it from the stack. Pop actually removes it from the stack. Okay. So it's called a LIFO type of data structure. It stands for last in, first out. So if we think about it, we're pushing things to the top. Whatever the last thing that got put on the stack was, is the first thing that we can pull out from the stack. Okay. Queues, on the other hand, are considered a first in, first out, or FIFO data structure. Queues are what you're used to at the grocery, at the Migros or A101 or wherever you go. If you're going anywhere for grocery shopping these days instead of having it delivered. But a queue, first in, first out, is whoever comes in first, they get to be serviced first. So, you know, it would be weird if Migros operated in a stack type of thing, right? Where if we have this group of people waiting, and the last person to walk up to the register is the first person to be served, that would be weird, and everybody would get very upset, right? A queue is much better. A queue for that type of function is the first person in line, they get served first, then the next, and so forth. A priority queue is similar. A priority queue just adds like an importance to each item. So a priority queue would be where we would use in like an emergency room in a hospital. Okay, so in that situation, you don't always serve the first person first, right? In a situation for a hospital, what we would do is we would say, if someone comes in and, you know, they have, you know, maybe they have a cut on their hand or something, but another person comes in and has, you know, an appendix that's about to burst, or you know, a broken bone or something like that, then we might serve them first, even though they came in second, right? And so what we end up with is the element with the highest priority is serviced first, is done first. And then if two elements have a similar priority, 2 people came in with cuts on their hands, 2 people came in with an appendix problem, then what happens is then it defaults back to first in, first out. Okay, so then it's like, okay, you were here 5 minutes earlier than the other person, but you guys have the same level of priority, so we're going to serve the person who came in first. Okay, so the queue, right? So poll and remove, offer and poll rather. I've also, what I would refer to these as is in queue and DQ, and I'll write that down. So basically, when we put something into the queue, we put it at the end of the queue, and when we take something away from the queue, we poll it, we DQ it, we remove the thing at the front of the queue, and then push the front of the queue back to whoever the next person in line was, the next value in line was. Okay, so let's just say that if we were talking about basic data structures of what we were talking about before, a stack would make a lot of sense if we did this as an array. Okay, an array or an array list, we could do a stack using an array or array list quite easily, right? Because we just, whatever the end of the array is, we look at that as the top of the stack. So we push to the end of the array, we pull from the end of the array. A queue, on the other hand, a queue would be a lot more difficult to do as an array because it's constantly moving. Where the front is, where we're pulling from, is constantly moving, and where we're pushing to, where we're queuing things to at the end, is constantly moving as well. And so that would be a lot harder as an array. So but doing that as a linked list makes a lot more sense. And so what you'll see is the way that this hierarchy results is a queue as a linked list makes a lot more sense. Okay, and you'll see why again when I do that whole whiteboard version type of thing. Okay. One example too that I would like you to look at. We'll look at a quick example of this when we get into it on the JGrasp here in a second. But how this expression is able to be evaluated using a calculator, like well, we did a calculator type thing. We did something like this last semester, but it was like a much more simple expression where it was just a single operator and two operands. Now we're going to allow for a lot more parentheses and multiple operations and stuff. And so we're gonna take a look at that and how the algorithm works. But I would like you to take a more in-depth look at that when you have time. Okay. All right. So let's go ahead and switch on over. Let's see this example here. 1 + 2 × 4 - 3. Okay. We'll keep a note of that. All right. So first, let's see. What were my 2 examples? What were my 3 examples I wanted to look at? I wanted to do the test array list. I wanted to do evaluate expression. What was the other one? There's one more in here I said we could look at if we had time. Was it the comparator? Yeah, I think it was the comparator thing. Okay, so we'll do the geometric object comparator and test comparator thing. We'll pull that up just in case we have time for that. Test comparator and geometric object comparator. Okay, with the geometric object. So that way we can see how that works. Okay. All right, so what I've done here is, what I want you to see is in this is I'm going to pull up this this guy here, the JGrasp canvas thing, so you can kind of see how these data structures are done. Hold on just a second. Okay, so what we'll do here is as we step through this, I'm gonna take this so that you can see what this looks like, okay? So you see that it looks a lot like an array. It's an array list, but it looks a lot like an array. And as we add these values, they just keep getting added to the end of the array list. So added 1, added 2. We're going to add 3 to the array list. It's going to get put here on the end. We're going to add 1 again. Notice duplicates are allowed in a list type structure. Okay. We're going to add 4. Now we're going to add at 0, so at index 0, the value 10. So that means we're going to try to put it here. Okay. Now this is not the same as set the value, right? Because adding it just inserts it here and moves everything else forward. Inside of the add method for the array list is all of the necessary code to move all this stuff forward in the array on its own. Okay. I can tell you the way you would do that with an array, right, is we would take the value that's in the last position and we would move it to the next position. Then we would keep moving things forward one by one. So what was in 4 got moved to 5. What was in 3 got moved to 4. What was in 2 got moved to 3. What was in 1 got moved to 2. What wasn't 0 got moved to 1. And finally, 0 was overwritten with this new value. Same thing here, and notice they're all red. They're all red because all of them got changed. What you're going to see in a second here when I click next now is I'm going to add to the 3 position the value 30. So I'm going to add to here something value here, right? And what's going to happen? Now only these values are, and the reason why is because these are the only ones that were changed where they were. Okay. We can display an array list. All right. Hopefully by now, when we call this print line array list, you know what happens. You know what method gets called that we don't see here. What method gets called here in order to display this array list. An array list is an object, which means it came from a class, which means that in order to print it, we had to call a method. Hopefully you know which one is. In fact, I think that would make for a really good quiz or exam question would be what when an object is printed. Okay, so let's see what happens when we print this. You notice it prints out kind of almost like in an array. So the method here that we called what it does is it displays. I'm gonna want to go back and I want to do something here. I want to say instead of add, I want to set so that you can see. What network am I on? Okay, sorry, I got a message saying that the network's having bad quality. Okay. So now instead I'm going to set, and we're going to see what the difference is here. Okay. So now, okay, so we add 1, 2, 3, 1, 4, and now we're going to set here instead. What's going to happen? It just changes that value. So set just overwrites what was there. Add takes everything that's at this position and later and moves it forward 1 and then sets that value. Set just changes that value. Okay, so that's a difference between the add and the set method. Okay, all right, so that's how an array list works. Now we're going to create a new linked list from the array list that we already have. Okay. Now notice we're doing it as a linked list of a type object, which means our array list that uses integers now is going to take any object. So I can put strings in it. Okay, and we'll see why this is. All right. So now, okay, I create a linked list, and now I want you to see how it looks different. Now, one thing I want you to know is that the way Java implements the linked list is what's called a doubly linked list. Okay, and basically what it is that each value here in the list, what it does is this node has a value, so in this case 10, and then it points to the next pointer to the next value in the list. It has a pointer to the next value in the list, the pointer to the next value in the list, and so forth. Okay. What that means is that in order to access a specific value in the list, we can't just access it using an index from the array. If we were to say give me, so get, select the get method. If we were to say get 3, for example, so I want the what would be at index 3, so the value 30 in this case. Okay. List works is it can't just access a thing at this index 3. What it has to do is it has to go to the first, then move to the second, then move to the third, then move to the fourth. It has to follow the pointers to get there, or it could start from the end and move backwards depending on how big the list is. But it cannot just access directly from the value here. So that makes the array so much better because I can just get to this value just by using the index straight away. Done. All right. Accessing values in an array is much better. Absolutely. But what we're going to see is when we go to add something, what happened when we added at 0? okay, or added at 3 is it had to move everything forward, right? It had to copy this into here, copy this into here, copy this into here, right? But when we go to add to the linked list, something different happens, okay? Notice this is the only thing that changed, right? Everything else stayed the same. 2 still points to 3, 3 still points to 30, 30 still points to 1, and so forth. And all of these other pointers all stay the same. The only thing that changed was we created a new node and had the pointers change. That's it. So moving stuff around becomes a lot more easy to do. Accessing a specific value, hard. Inserting a new value is super easy. Okay, so array lists, accessing values are easy, inserting new values are hard. A linked list, accessing specific values in the list, hard. Inserting new values becomes a lot easier. Okay, we can also add first here, or sorry, remove last. So to remove the last, we're simply gonna, what we're gonna do is we're gonna take this last pointer, we're gonna point it to here instead, and we're gonna take this pointer at the end and set it to null. We're just gonna just this value here. To get rid of it, we just have to stop pointing to it. Okay. So what's gonna happen? Done. We just changed this pointer to be to this new last element, and we simply took this pointer and removed it. We set it to null. It's no longer pointing anything. Okay. We're gonna add a first item. We're gonna add to the first green. Similar to the remove last is we just change pointers again. We change what the first is pointing to, and we change what other things are pointing to. Okay. So just do that. We create this new node. First now points to it. This now points to this, and this points to what first used to point to. Okay. All right. So if we wanted to display the linked list backward, we could do that. Now we can use an index to get that value, right? But every time that we do, right, in order to get to that value, we can start here at the last, but we're going to have to use a following of the pointers to get to a specific index. Okay. So we can still do it. It just, yeah. So this right here, I wanted you to see this, and I'll draw this out on that whiteboard tool so that you can see it a little bit better as it gets developed. Okay, is the difference between an array or array list type structure versus a linked list. Okay. All right. So let's close this out. All right. I also wanted you to look at this. So I have this in there, but that's not what they gave us, was it? It was, I want to use the same example one here so you can see it here. 1 plus 2 times 4 minus 3. Okay. 1 plus 2 times 4 minus 3. Okay. I'm gonna go ahead and do this. Okay. So we have this operator stack and operand stack and tokens. So what we're going to see is, oh, I just stepped over it. Whoops. Okay, we'll go back and do this again. Right. I gotta step in to there. Okay. So now we're creating this operand stack. Okay, this is going to start with nothing. We're going to create this operator stack, right? And if you look at this, you might realize that this looks a lot like the array list, doesn't it? It doesn't look like the linked list. And that's because an array is a much better data structure for a stack. And because we can put to the end and we can get from the end very easily, right? Okay. All right. Not as good for the queue, right? Because a queue would mean we'd have to move everything forward. A linked list is a much better structure for a queue because in order to remove of an item, we just have to grab it and stop having it point to the next item and have the first point to the new next item, right? Okay. So what we're going to do is we're going to notice that the expression, it inserted a bunch of spaces so that we could use the split method to create an array of tokens, an array of things. Okay, so if we look at the tokens, notice now our tokens are all a bunch of, our characters are parentheses 1 plus 2 times 4 minus 3, right? So our token array is the aspects, the part of our expression here. Okay. So now what we're going to do is we're just going to go through each token one by one. Okay. Token is nothing, so we don't do anything. We're just going to continue. Okay. Next token is going to be what? A parentheses, an open parentheses, right? So is it one of those? No, so we move on. Is it one of those? Star or slash? No, we move on. Is it this? Yeah, we found a winner. All right, so what are we going to do? We're going to push this to the operator stack. So we should see it show up here in the operator stack. And there it is. Now we're done. Now our next token is a number, right? 1. So it's not an operator, not an operator, not a parentheses, not a close parentheses. So now we're going to push this token. Now remember, this token is what? It's a string, but we're going to take it and create an integer from it so that we can put it to our operand stack, which is type integer. All right, we can do that. We can convert that to an integer. There it is. Okay. Next. What's the next thing? It's plus. Okay, well we've hit something here. Good. All right. Now the operator stack, is it empty? No. So while it's not empty, which it's not, so that's true. Okay. And all right, if the next thing is one of these, okay, well that's not right. It's not one of those. So we don't do anything. This while loop doesn't do anything. We're not processing an operator. Okay? So we're just going to push our operator to the stack. So it gets pushed to the top. Okay. Now, what's our next one? 2. Hopefully you realize what's going to happen here. All right, it's going to be none of those things again. So we're just going to push it to the stack here. All right. Okay, so now we're going to do this close parentheses thing. Okay, so what we're going to see is, it's not that, it is this. Now it's closing the parentheses, all right? So while we look at the next one, as long as it's not, is the next one off the top of our operator stack, is it this closed parentheses, this open parentheses? No, it's the plus sign, right? So it's not that. So we want to process an operator. So we're going to process the operator. All right, so let's see how we do that. All right, what is the operator? We're going to pop this operator off the stack. So plus is gone, and now it's over here. It's in this variable op. Okay, we're going to pop the operand off the operand stack. So what's going to happen? Op1 will get this value, 2, and it will disappear from the stack here. Op2 will get this value, and it will disappear from the stack. So now our stack is empty. But you might be like, wait. We have this operand stack is empty, but we don't have any operands. But we have this other thing out here. Just wait, we'll get there. All right. Operator is plus. All right. So what we're going to do is we're just going to simply push onto the stack the sum of those two. Notice plus, minus, star, slash. Okay. There is no method like what we did up here with this. You took a string and changed it to an integer because we knew it had to be an integer value. There's no method like that to be able to take this plus and do this with it, or take this minus and do that with it. There's no automatic conversion like that exists. If you want to write that, that'd be great. So anyway, all right. So what's going to happen? We're going to push to our operand stack the sum of 2 and 1. So when we do that, there it is, 3, done. Okay, so we processed the operator. Now, is that next value in the operator stack this close parentheses? Yes, it is. Okay, so what we're going to do is we're going to pop it. Now notice that we popped this and we didn't assign it to anything. Down here, when we popped the operator off the operator stack or popped the operand off the operand stack, we assigned it to a variable. We can do that because this returns a value, but here we don't have to return value because we don't need it. We don't need that parenthesis symbol for any reason. We just needed to know that it was there, and that's enough. So we're just going to get it off our stack. We don't want it in our stack anymore. And so, but we don't need to assign it to a variable. We don't need the value. Okay, so we're just going to get rid of it. It's going to get removed. And now we have 3, and the rest of our tokens, the next token after that should be, whoa, it's going to be a space first, actually, blank space. Okay, the next one is going to be this star here. So now we're going to multiply. Okay, if operator stack, well, it's not empty, we're going to process an operator, but actually the operator stack is empty. So this is true, which means not true is false. So we actually won't do this while loop. Okay, now we're going to push the token onto there, onto here. Now we'll move on. We'll do 4. We're just going to push that onto here. Okay. Our token is a minus. Is it empty? No. Okay. So it's not empty. So is empty is false, not false is true, and the next operator is going to be one of these, isn't it? Right? It's going to be a plus or a minus or a star or a slash. Right? There it is. All right? It is one of those. So we need to process this operator. And the reason for this is because we're looking at a minus, sorry, in this case a minus, right? But we have a star, a multiplication that's there, which has a higher priority. So we need to go ahead and get these two taken care of before we try to do this, before we try to do the subtraction. Okay, so we're going to process that same way we did before, where we popped, and we put them all together, and 3 times 4 is 12. So now we're going to push, because our operator stack is now empty, we don't need to do anything else with it. We're going to push that subtraction symbol onto there. And then we're going to push 3 onto there. So now this for loop is done, right? We are done. But you're like, wait a second. No, we can't be done. Mm-hmm. We're done with the processing of the tokens, but as long as the operator stack still has stuff to do, while it's not empty, we want to keep processing an operator. Okay. You should realize that however many operators there are, we should have one more than that as for the number of operands. Okay, so we have 1 operator, 2 operands. We're going to process this operator the same way we did before. 12 minus 3. It's going to push to here, Is the operator stack empty? Yes. Right? And so now we're just going to return what, and the way this should work is this should just have one value in it. We're going to pop that off and we're going to return that value. So that stack is now empty. This returns 9. We now print 9 to the screen. Okay. All right. I encourage you to take this evaluate expression to go look into the lecture examples folder here that's available to you. Take a look at this, play around with it, change this up some, have some fun with it, and see how it works and how everything goes together. Okay. I'll just very briefly talk about this whole geometric comparator thing. No, basically the main difference is that right now, so geometric object does not implement the comparable interface, right? So it is not on its own a comparable object. But what we can do is we can define a comparator for it, right? Geometric object comparator, right? That implements the comparator interface to create a way to compare two geometric objects to each other. Okay, so here, this is how we would do that. Basically, we've decided in this example to do it by area, that if the area of 1 is greater than the area of 2, then that's considered greater. If they are the same area, then they're considered equal. If area 1 is less, then it's considered to be less. Okay, so the way that we use this is, since geometric object on its own is not comparable, in order to compare the two, we must pass the two objects we want to compare to each other and a comparator that we can use for the two of them, which we've defined here. Okay. So I hope that's clear, that by comparing them to each other here, what we could have done, right, for the max here is we could have, instead of having it be defined using this comparator thing, is if we want to remove that, we want to remove this, we could have simply said if g1.getArea is greater than g2.getArea, return g1, else return g2. We could have, by comparing it by area, but then how do we define min? Well, I guess it's the same thing, but we have to do it by getArea. This just makes things a little bit more consistent in terms of how we compare two items to determine which one can be considered greater or last or whatever. However you want to define max and min and stuff like that. So if we were to do it without the comparator and without implementing the comparable interface here, then what we'd have to do is, if we wanted to change for some reason, what if instead of by area, we wanted to do it by something else, like color or what date it was created, right? What if we wanted to change what our definition of greater was? Then what would have to happen is, in all of our max, min, sort methods, we would have to change all of those methods to reflect that change in what greater is. Whereas if we have the comparator interface, we can just change it here, what greater means. Okay, I kind of breezed through that very quickly, and so if you want to know more about this, we just message, maybe make a message in here, and what we can do is I can go into it more in depth next week during our Wednesday lecture. But basically, I just wanted to introduce you to another way for how you can compare two things to each other. It's much better if we don't have to change a lot of methods to reflect a simple change like what the definition of greater is. Whereas if we can change it in a comparator like this, or if we can implement the comparable interface and change it in the compare to method, that becomes a lot easier than having to change it in max and sort and all of that stuff. Okay. All right. So I hope that's clear. I'll stop sharing my screen now, and I'll go ahead and put my camera back on. So if anyone has any questions or comments, please go ahead and make them known now. And so otherwise, we will, like I said, we'll end there for today as far as this video lecture is concerned. And as I said, be on the lookout for a by hand drawing that I'll be doing for to help you understand a little bit better array list and linked list and how those data structures work. Okay. All right. So if that's it, then I will end the recording and I will see you guys.